Hello dear students, welcome to my YouTube channel. How are you all? I hope you all are doing good. So in this video I am going to give the list of formulae for the chapter electric potential and capacitance. So I have already done with a few videos in which I have made the list of formulae for different chapters, and this is one of them. Okay, so now let us start with this. Yes. Okay, dear students, let us take the first one, that is the electric potential. Electric potential. How do we define electric potential? See, electric potential is the amount of work done in bringing a unit positive charge from infinity to that point. Or if you consider any charge which you are moving, that charge is written here. So electric potential is defined as work done divided by the magnitude of moving charge. Okay, and what will be the unit for this? So for work done it is joule per coulomb for this one, or you can just write volt. Okay, next, second one is electric potential difference. Electric potential difference. These formula are very important. Take a notebook and note down all this at a point. So if you are moving a charge from one point to another point in electric field, so we need to consider, let me consider this is VA, this is VB at two different points A and B, are the two what is that, points where electric potentials are VA and VB. Now what is the amount of work done to move the charge from B to A? Okay, where let us consider potential at A is greater than potential at B. Okay, so now the amount of work done is given by, okay, let me write electric potential difference VAB is equal to amount of work done to move a charge from B to A divided by Q. Q is the magnitude of moving charge. So now I need to calculate what is that work done. So you can write like this: VAB is written as VA minus VB, or you can also write like this: potential difference between VB point B and A, because we are moving the charge from B to A, right? Let me write VBA, and work done to move the charge from B to A. Here you will write this like this: VA minus VB. Why? Because VA is greater than VB. Okay, now we can write like this: that is equal to work done to move the charge from B to A divided by Q. You just have to use this formula to calculate the work done under potential difference, or Q. Okay, next, formula number 3. What is that? What is the expression for electric potential due to point charge? See, till now I have given the definitions for electric potential and potential difference. So this we can apply for different types of charges also. Like if we consider one charge, what is the electric potential? Two charges, what will be the electric potential? N number of charges, what will be the electric potential? Like that. Okay. Now for a point charge, for a point charge, what will be the electric potential? Let me consider, here we have a charge Q. What is the electric potential due to Q at this particular point, which is at a distance R? So that is given by V is equal to 1 over 4 pi epsilon naught. So charge we have here, that is Q divided by distance R. Okay, if distance is D, write down D here. If distance is X, write down X there. We have the R distance. So here variables are Q and R, where 1 by 4 pi epsilon naught value is fixed. How much is that? You have studied that in first chapter, where 1 divided by 4 pi epsilon naught value is 9 into 10 to the power 9 units. Newton meter square per coulomb square will come. So it will be in units. Okay, so that is the value of that. Next, coming to the fourth one, electric potential due to dipole. So what is dipole, dear students? See, if you consider what is that, two equal and opposite charges. Let me consider a positive charge here, negative charge here. They are separated by a small distance a, 2a. Okay, or you can consider x also, l also, a also, whatever it may be. So then, what is the electric potential here? You must have studied this in board examination, boards theory part already. If you have not done with the theory concept, please do complete that, and you can understand this formula, list of formula easily. Otherwise, directly if you come and try to understand this will be difficult. Okay, now first you have to study the complete chapter, then you have to take note of all the formula like this. Next, so what will be the electric potential at this particular point due to this dipole? So here we have positive charge, here we have negative charge, distance between them is 2a. Then what is the electric potential here? That is given by V is equal to 1 over 4 pi epsilon naught P cos theta, small p cos theta divided by r square. Okay, na? So this is the formula for electric potential due to dipole. What is that? Electric potential due to electric dipole, not magnetic dipole, it is electric dipole. Okay, so here for point charge we have this 1 by 4 pi epsilon naught q by r, and for dipole this is the formula. What if we have n number of charges? So what is the formula for that? For system of charges, maybe positive or negative, okay, whatever it may be. So let me consider here we have charge q1. What is the electric potential due to that? Here 1 by 4 epsilon naught q by r. Let me consider this is distance r1. Okay, this is the charge q2, distance is r2. This is the charge q3, distance is r3. This is the charge q4, distance is r4. This is the charge qn. Okay, let me consider nth charge, distance is rn. Like that there will be many charges. So what is the electric potential due to all these charges at this particular point P? So it is given by V is equal to V1 plus V2 plus V3 so on up to Vn. So that's why this is called superposition principle. So what do we call this principle? Superposition principle. Okay, na? This is called superposition principle. Next, so next we have V is equal to what is V1? 1 by 4 pi epsilon naught q1 by r1, right? And what is V2? 1 by 4 pi epsilon naught q2 by r2. Like that we get many terms like that. So let us take common in all of them. What is that? 1 by 4 pi epsilon naught. So remaining I left with this concept. Yes or no? In superposition principle you will learn this. Next we have can I take the use of summation symbol? Okay, that is from qi to ri, where I varies from 1 to n, where I varies from 1 to n. So we can write like this is the fifth formula. Next, formula number 6. Relation between electric field and electric potential. Electric potential. What will the formula? See, we have derived this by using what is that? Equipotential surfaces. For 3 marks we have a derivation, right? There we have derived this. So if you consider 3-dimensionally, you will get this. Especially this we use in NEET level. So dv by dx plus into I cap is also there, plus dv by dy j cap plus dv or rho v by rho z k cap. So this is the relation between electric field strength and electric potential. So for boards there is a derivation for 3 mark based on this. Okay, if you check you can get an idea. Next, 7th one, expression for electric potential energy. See dear students, we have studied that V is equal to work done to move a charge Q from infinity to a given point, right? So this work done is stored as potential energy in the system. Okay, so multiply this Q this side, so potential energy is equal to Q into V. Okay, let me write it again. So you have got an idea how did you get this electric potential energy. So expression for electric potential energy, electric potential energy. So in general we write electric potential U is equal to Q into V, and you have got an idea also how did you get that. Then for system of two charges, what is the electric potential? U is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R. This is for a system of two charges. Okay na? What if we have three charges? This is for system of two charges. Next, system of three charges. U is equal to 1 over 4 pi epsilon naught Q1 Q2 by R12. If I consider this is the distance between first charge and second charge, then second charge and third charge divided by R23 plus third charge and first charge divided by R31. This is for system of three charges. Okay na? This is all about electric potential energy. Okay na? Next, 8th one, potential energy of dipole potential energy of a dipole placed in uniform electric field. Okay na? Then here if you place an electric dipole inside a electric field, and that too uniform electric field, it experiences a torque in this direction. So if you do some work against it to move in opposite direction, that work done is stored as potential energy. So after calculation you will get a formula like this, that is minus P sin theta. Okay na? No, sorry, sin theta means cross product will come cos theta. So in vector form, potential energy is written as minus P dot E. Okay, U is a scalar quantity, potential energy is scalar quantity. What is P here? Dipole moment. Okay, where P is dipole moment. Next, what is E? Electric field. Okay, next, ninth one. What is the expression for polarization density, or let me consider susceptibility? Which one you want? I will only give electric polarization. Okay, see, if you have studied the concept of dielectrics, you get an idea here about this. Electric polarization is directly dependent on electric field, and if you remove this proportionality sign, you will get a constant called chi. Okay, so this is represented by the symbol chi. Here chi is called electric susceptibility. Electric susceptibility. P is called dipole electric polarization. E is called electric field strength, resultant electric field. Okay, this is resultant electric field. Now, next one we have the capacitance concept. Capacitance of a capacitor is given by capacitance of a capacitor. Okay, so if we consider there is a capacitor here, spherical capacitor, which is having some charge stored on it. What is the extent to which it can store charges? The ability to store charges, it's called capacitance. The ability to store charges is called capacitance. So for mathematically it is given by C is equal to Q by V. Okay, so for remembering this in easy way, we usually write like this: Q is equal to CV. Okay, then C is equal to Q by V will come. Okay, next, what is the capacitance of parallel plate capacitor? That is the 11th formula. Capacitance of parallel plate capacitor. So capacitance of parallel plate capacitor is given by, see, this is the symbol for parallel plate capacitor. If this one is charged with my plus Q, this one will be charged with minus Q, and there will be electric field generated between the plates. So here capacitance formula C is given by epsilon naught A divided by D. What is A here? A is called area of each plate. What is the area of this or this? And distance between the plates is given by small d. Epsilon naught is the absolute permittivity. What is the value of it? 8.85 into 10 to the power minus 12 units. Okay, so SI units. Next, we have capacitance of parallel plate capacitor in the presence of dielectric medium. See, if you consider a medium is present between the plates, okay, dielectric medium is present between the plates, then how do you consider the capacitance? Will it increase or decrease? So C is given by epsilon naught A divided by D into K. So capacitance increases by an amount called K, where K is called dielectric constant. So electric constant. Have you studied this for exam, board examination? So you should complete understanding the theory parts completely, like derivations or the conceptual topics and all. So then only you can understand this formula easily. Okay, next, formula number 12. What is the next one? What is the equivalent capacitance of capacitors connected in series? So if you consider n number of capacitors in series here, let me consider two capacitors C1 and C2. What will be its equivalent capacitance? Let me consider, since they are connected in series, so series combination is there. Series combination. So if we consider, so the capacitance of equivalent capacitors is given by 1 by Cs is equal to 1 by C1 plus 1 by C2. Okay, or for our convenience, for numerical purpose and all, we solve this and keep like this. Cs is equal to C1 C2 divided by C1 plus C2. Please make sure you are using this formula for exam purpose, numerical purpose, because if you use this, you have to take LCM and all, then you have to solve. But if you use this, this will be very easy. Okay, next, if capacitors are connected in parallel, okay, between two plates, points, here one point is there, here one point is there. So this capacitor and this capacitor C1 and C2 are connected between points A and B. Then equivalent capacitance CP is given by C1 plus C2 plus C3, so on up to Cn. How many capacitors you are connecting? Okay, dear students, so if you take these two cases and solve for n number of capacitors, let me consider 1 by Cs is equal to, for series combination, you get 1 by C1 plus 1 by C2 plus 1 by C3, so on up to 1 by Cn. Like that, there are n number of capacitors connected in series. Like this, n number of capacitors connected in series up to n times. And all the capacitances are same. Capacitance of this one is C. So what do you get here? Ultimately, if you add, you get n times 1 by C. So 1 by Cs is equal to what? N by C. What about Cs? C by n. So if similar type of n capacitors connected in series, then equivalent capacitance is given by C by n. So do remember this formula. Okay, so in the same manner, if n number of capacitors connected in parallel, then Cp is given by n times C. Why? Because in parallel combination you get C1 plus C2 plus C3 plus C4 plus C5 plus C6, like that. So if you add all C's, you will get n times C. These two formulae are very important for numerical purpose. Next, moving on to formula number 14. What is the expression for energy stored in a capacitor? Energy stored in a capacitor. Energy stored in a capacitor. So it is given like this: U is equal to half CV square, or you can also write Q square by 2C, or you can also written as Q by if you substitute like this, Q into E, half Q into V also you can write. Like this we can write different formulae for energy stored in a capacitor, and there is a derivation also. Okay, so for this year, this is the list of formulae which is very important, and energy density also you can write down, which is there, but for this year the derivation has been cancelled for boards, but for first I write down energy density of an electric field between the parallel plate capacitors, between the plates of the parallel plate. Here electric field will be there, right? This electric field is given by E, and energy density is given by half epsilon naught E square. Okay, so if I have missed any formula, you can continue after this. You can refer the textbook, you can refer the notes which is given in the college, or you can refer the any material that you get, the best material that you get. Okay, so these are the list of formula, dear students. Hope this is helpful to you. It will be helpful to you. So if you feel so, please share it to your friends. Till then, take care. Bye bye.